So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 282 and in this video we continue with our copy constructor and we will watch now these examples here below. And it is very important that we also talk about shallow copy and deep copy while we are watching these examples, because we start here with the struct A and you can see they have here a normal constructor and here a user-defined copy constructor. So now the difference about the user-defined copy constructor and the implicit defined constructor is that we are providing this one, and when we are providing this one we have most times something special to set up. In most cases there is a allocated memory and the normal implicit copy constructor will not handle it. Then you are providing, for example, a copy constructor on your own so that it can make the so-called deep copy. But before we go on, let's talk about shallow copy and deep copy again. The shallow copy, what many people talk about, is a copy which is just copying one by one without a deep copy. For example, if we have here an int n, then the shallow copy is just creating another int n in the next class and then assigning the values there. But the problem with the shallow copy is, for example, if you have here provided or the allocated memory, that the shallow copy is not allocating memory for you in general, but there are certain exceptions which we have to talk as well. And then so you have to make here a deep copy, which means just you are defining this user-defined copy constructor and then you are creating this allocated memory here in this body and assigning them how it should be done. The next thing is what we have to talk is what it means shallow copy and deep copy in general. So because there is a mistake, they think the compiler will, when it creates implicitly a copy constructor, not this one here, this one we have provided here. So when the compiler is creating implicitly a copy constructor, most people think it will automatically make a shallow copy, which is most time true, but not all time, and that's the problem, because the copy constructor here, the implicitly declared one, is just doing this one here. It says here for non-union class types, class and struct, the constructor performs full member-wise copy of the object spaces and non-static members in their initialization order using direct initialization. So it says not I'm doing a shallow copy, it says I do only a full member-wise copy, but this member-wise copy could have also be implemented with deep copy, and then the implicit copy constructor would also do a deep copy, and that's the problem what many people forget. And yeah, but a general thumb rule is, if you are not certain, just make your own user-defined copy constructor, which will be perform definitely a deep copy, so you don't have to guess is it doing a deep copy now or is it not doing a deep copy. So then let's watch a little bit these examples here. So you can see here we provide a user-defined copy constructor. Here we just inherit from A. There is nothing in it, but again, nothing means not real nothing. The compiler is creating, you can see the default constructor here like so, and then the implicit copy constructor like so, and even the compilers even create here much more things which we will have also to talk later. And then we inheriting again from this one, and here we have a public constructor which is calling the B constructor, and then we have here private, and private is careful. What means private here? You can see they have already set it non-copyable, which means if you set a copy constructor, this is one, to private, that means struct C can't be created a copy of that. So if you try to create a copy, you get a compiler error, but you can set this to public and then that should work again. All right, then let's go here to this one. Most of these examples we know. Very important is if you here, they create just a normal object. This is our A. And then while they creating an object, an important copy constructor works only while you're creating an object, and then pass the argument in here, which is another object of the same type here. And you can see indeed A1 is the same type. We're passing this an argument, and then our copy constructor, this one will be called. And yeah, that's very easy here. The same go, and here important, they are using here a direct initialization, and they are doing now it with B. B is this time with an inherited class, and here they are creating again and initializing at the same time, and B is here this time copy initialization. And then what they are doing here is they are creating again an object A3, again a copy initialization, and here we have a problem. You can see A and B have a different type, and that's why there is a conversion. We know that works because they have inherited from each other, but still careful, there is a cut later even if inherited, but still it converts this and then calls the copy constructor. We're about this volatile keyword, we have talked about it. Is more a compiler instruction, and it says you should not optimize it. And if you have something like that, then we have here an error, because here, let's see, this one is again, we create a new object here, AA4, and then we try to assign a volatile object. Volatile object means don't optimize this one. You are not allowed, as a compiler, you should not optimize this. So instruction. And the problem here is this one is volatile, this one is not volatile, which means here the compiler would try to optimize. Here we have instructed the compiler not to optimize, and then it gives a compile error that says can I optimize or not optimize now? And that's why no, here it's not clear. All right, and here in C we are creating a C object, and here we get a C error. Let's check why we get there in C error. That was this example with this private. If you set your copy constructor to private, you can see then it's not copyable. You have a C, you make a C2 here again. Normally when we see this kind of stuff, we expect it should be easy copyable, but no, it's not allowed because it's set to private. All right, that's very important, and that's all what we have here for this copy constructor. And again, last hint, don't make the mistake with the copy assignment operator when you have here an object, for example this one, and you have here another object. Okay, let's say we have here another object finished, and then they are using this equal sign, because then it's not calling the copy constructor if you make just an assignment. Well, let's make here an example. Do I have here? No, I have not here an example. Let's make this one here. Let's say I have here AA5, anything like so, and then we say A5 equal A1. This one is creating also on copy. Let's see if this is true, if this is working. Yeah, it works. So you can see this one is also creating a copy, but this one is the copy assignment operator, not calling the copy constructor. And why is this so important that you know this one? Because let's go back to our user-defined constructor. For example, one of these objects here has allocated memory, and you have defined how to copy the user-defined how to copy our allocated memory to another, and this one will just not call your copy constructor, and then you are not allocating this memory, and then yeah, that can cause let's say this so-called shallow copy, which means just copying pointers instead of the underlying resources, and that will cause a problem. But we will talk anyway about the assignment operator in the next video. Okay, that's all for this video. If you have any questions or anything, again, write in the comment section. See you in the next video. Bye, good luck, and like all time, have fun.